Welcome to see a demo of TPS Theorem Prover for Scientists version 0.01. I will give axioms and conclusion. First axiom: x plus y minus z is 5. This is lower bound and upper bound. This is same as 5. Y plus z is 3 and z is 1. And then we add conclusion. And then you press the prove button. It proves the conclusion starting from axioms. Now we press this button. And here we see the proof. It starts from the end and proceeds to start. Hello, my name is Mikko Malinen, and this time I tell you about TPS version 0.01. It is a theorem prover for scientists. Here you see a possible input for this kind of theorem prover. It has axioms, axiom 1 and axiom 2, and the conclusion. All this has to be given as input to the theorem prover, and the theorem prover gives an answer that is it proven or not. And it is the first version of this TPS, and it's very simple what it can do now, but it's expandable. Axioms may be given as input. The theorem prover, it has inference rules now. It has only one inference rule, and then it produces inferred theorems and adds those to the list of theorems. And it can further process the new theorems or statements later time in the execution of the prover. And the conclusion has to be given as input. The statements are stored as a trees, and there are two numbers where we normally see only one number. This means that the actual number is between 5 and 5. It's interval arithmetic. This is because both numbers in computer are approximations. Very often That's why we have to put the lower bound and upper bound to maintain accuracy and correctness, to maintain correctness. Here's the structure of the prover. It takes some statements from the list here and here, and then it takes rule from rules list, and it produces a new statement, and it puts it to canonical form. I will tell you later what is canonical form, and then it adds to the end of the statement list. And statements are processed from start to end, and at some point the new statements will be processed also. So there may be coming new statements from the new statements, earlier statements. Here we see why canonical form is important. We have a theorem here. We have another theorem here. The canonical form is that if you have two equivalent theorems, then the canonical form are similar for those two. And from the canonical form, we can see equivalent if the theorems are equivalent. Let me see an example problem which could be even seen, but not this first version. It's more complicated. Here's the input screen. Axioms are written here, on one line, and conclusion is here, and we press prove, and we get the proof. This simple problem also written is now proven after 9 statements. It starts from the end, from near the conclusion. It produces, it proceeds to the beginning. It's long. One more thing. The parser rules for the Theorem Prover are here. There is equation and an expression. Expression can be a number, variable, bounds. There's the interval arithmetic lower bound and upper bound, or expression plus expression, or expression minus expression. So thank you for listening, and I would like to receive comments if you have any, and see you next time.